Hello students, welcome to your channel Parivartan Physics. See, we are in the series of videos where we are going through a course called as Rapid Revision course for Kcet 2025. Till now we have revised up till dual nature of radiation and matter, and in this video we are going to revise atoms and nuclei together, as I have told you in the earlier videos itself. So lastly one the chapter with the semiconductors that we'll see in the next video, so that will complete your second PUC syllabus, right? Fine. So without wasting any time, let us begin with atoms and nuclei. And we know very well in these videos we are revising the concepts, the shortcuts, the formulas of a complete chapter in one video, right? So in this video we are going to see these two chapters together, atoms as well as nuclei. Dear students, if you like the content of this channel, please don't forget to subscribe the channel and share the video, share the channel with your friends, right? Okay, let us begin. Scattering of alpha particles. We know very well at the beginning of the chapter we have a experiment called as alpha scattering experiment, right? And in that experiment we have seen number of alpha particles is scattered at the small angle. See, here the angle is small. Number of alpha particles scattered at a small angle is very less, and number of alpha particles scattered for a number of alpha particles scattered for large angle is very small. So very less number of alpha particles will get scattered by a large angle, and very more number of alpha particles will get scattered for a very small angle, right? Antandre number of scattered particles are very less for large scattering angle, and number of alpha particles scattered which are very more or very large for small angle of scattering. So here we can say number of alpha particles is scattered. N indicates number of alpha particles is scattered is inversely proportional to sin raised to 4 theta by 2. Sin raised to 4 theta by 2, where N is number of alpha particles, theta is scattering angle. Theta is scattering angle. So as the scattering angle increases, number of alpha particles decreases. Number of alpha particles ನಮಗೆ decrease ಆಗ್ತವೆ, right? 10 degree 20 degree ಒಳಗೆ ಜಾಸ್ತಿ number of alpha particles scatter ಆಗಿರ್ತಾವೆ, right? 120 degree 180 degree very less number of alpha particles will be scattered. So scattering angle ಜಾಸ್ತಿ ಇತ್ತಂದ್ರೆ number of alpha particles ಆ angle ಒಳಗೆ scatter ಆಗೋದು ಬಹಳ ಕಮ್ಮಿ. Small angles ಒಳಗೆ ಜಾಸ್ತಿ number of alpha particles scatter ಆಗ್ತವೆ, right? That is all about the relation between number of alpha particles and the scattering angle. Next, distance of closest approach. See, if this is a positively charged nucleus, and an alpha particle is passing through this, from here if it is passing, as it comes close to the nucleus, it will experience a repulsive force and it will get repelled, right? It will get deviated from its original path. So how much angle it has deviated, this is called scattering angle. This is scattering angle anta karitare. See, when that alpha particle is very far from that nucleus, at that time the perpendicular distance between the direction of the alpha particle and the central line of the nucleus this is called impact parameter, and it is represented by B. Impact parameter, and it is represented by B. See, if we move close to the nucleus, it will get deviated more. You know, E alpha particle is to deviate agitri. If I take an alpha particle moving over here, close than that, if I take alpha particle which is moving close than the earlier alpha particle, this will get scattered more. If I take any another particle, that will get scattered more than that. So as we move close to the nucleus, more it will get scattered, and as we move far from the nucleus, it will get less scattered. Adu kadime scatter namaga agtade, right? So here, see, next, if I send an alpha particle exactly along the central line of the nucleus, a nucleus ಏನದ exact as nucleus of the central line kana ನಾವು ಒಂದು alpha particle ಅನ್ನು ಏನಾದರೂ ಇನ್ಸಿಡೆಂಟ್ ಮಾಡಿದ್ರೆ, that alpha particle will move up till a certain distance and it will get rebounced. On certain distance ತನಕ ಹೋಗಿ ವಾಪಸ್ ಬರ್ತದ್ರಿ, right? Up till this point ತನಕ ಹೋಗಿ ಅದು ನಮಗೆ ವಾಪಸ್ ಬಂತು ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Then this distance ಅಂತಂದ್ರೆ its final point and the point where the nucleus is present, the distance between that is called distance of closest approach. ಇದಕ್ಕೆ distance of closest approach ಅಂತ ಕರೀತಾರೆ. More the velocity, less will be the distance of closest approach. So that distance of closest approach, at a distance of closest approach ಅಂದ್ರೆ ಈ ಪಾಯಿಂಟ್ ಗೆ ಬಂದ ಕೂಡಲೇ ಏನಾಗಿರ್ತದಪ್ಪ ಅಂತಂದ್ರೆ kinetic energy of that alpha particle will be equal to the potential energy of that alpha particle. Kinetic energy means it is half mv square, potential energy means it is k q1 into q2 divided by r, where k is 1 by 4 pi epsilon naught. So you can use this relation, or we can directly use the formula of impact parameter. Impact parameter ಅಂತಂದ್ರೆ ನೋಡ್ರಿ, B is the perpendicular distance. Impact parameter is the perpendicular distance of the direction of the alpha particle from the central line of the nucleus when it is far from the nucleus. Nucleus ದಿಂದ ದೂರ ಇದ್ದಾಗ ಅದು nucleus central line ದಿಂದ ಎಷ್ಟು ಮೇಲ್ಗಡೆ ಅದ, ಎಷ್ಟು perpendicularly ದೂರ ಅದ, that is impact parameter. It is given by k ze square cot theta by 2 by kinetic energy. Okay, Kze square cot theta by 2 by kinetic energy. Right, this is impact parameter. See, if impact parameter is more, scattering angle will be less. If B is more, see, for this impact parameter is more, so either the scattering angle namu kadimade, either scattering angle kadimade. For this impact parameter is less, so either the namu scattering angle ಜಾಸ್ತಿ adri, more scattering angle it has. So more the impact parameter, less the scattering angle. If impact parameter is 0, it will get rebounced. Scattering angle will be 180 degree. It will get rebounced, right? Okay, let us go to the next concept then. See, next is radius of nth orbit of an electron. See, nth orbit ಒಳಗಿರುವಂತ electron radius ನಮಗೆ orbit ಎಷ್ಟಿರುತ್ತಪ್ಪ ಅಂತಂದ್ರೆ it is given by n square h square epsilon naught divided by pi m z d square. This is the formula for nth orbit of an electron. And if you see, n and z are only the variables here, rest all the things are constants. ಉಳಿಕಿದೆಲ್ಲ constants ಅದಾವ್ರಿ. So if I substitute all the constant and if I simplify, I will get the number 0.53. So radius of nth orbit is equal to 0.53 n square divided by z. It means radius of nth orbit is directly proportional to n square and inversely proportional to atomic number. Next, velocity, orbital velocity of the nth orbit electron is given by z square divided by 2 epsilon naught nh. Here also z and n are variables, remaining are the rest of them are the constants. So if I substitute the constant, I will get velocity of the nth orbit is equal to 2.2 into 10 raised to 6 z divided by n. It means velocity is directly proportional to z, inversely proportional to principal quantum number n. Next, energy of nth orbit electron, m z square e raised to 4 divided by 8 n square h square epsilon naught. So here also z square and n square are the variables, remaining are the constants. If I substitute all those things, I will get minus 13.6 z square divided by n square. This is energy of nth orbit electron, right? So you use these formulas only to calculate radius, velocity or electric energy, right? Negative sign indicates we have to supply energy to remove an electron from an orbit. We have to give energy to remove an electron from an orbit. One orbit daginda electron you ತೆಗಿಬೇಕಾದ್ರೆ energy ಕೊಡಬೇಕು. That indicates negative sign. So energy of nth orbit is directly proportional to z square and inversely proportional to n square, right? Okay, next, time period. Time period of that revolving electron is directly proportional to the cube of principal quantum number. Frequency is inversely proportional to the cube of principal quantum number. Kinetic energy and potential energy both are inversely proportional to square of that principal quantum number, n square, inversely proportional to n square. N is principal quantum number, number of orbit andangri, right? Okay, so remember the relations. In next nodri, principal quantum number. Igille energy formula antu namagu gottada. We know the formula of energy. Energy of nth orbit is minus 13.6 z square divided by n square. This is the formula, right? Z square divided by n square. This is the formula of nth orbit. If I substitute n is equal to 1, first orbit energy we will get for hydrogen atom, right? This is for hydrogen atom, right? So for hydrogen atom, if you substitute n is equal to 1, hydrogen atom antandre z is equal to 1, atomic number is 1. If I take the first orbit of hydrogen atom, n is equal to 1, we have to substitute. Energy of the first orbit of the hydrogen atom will be minus 13.6 electron volts. Second orbit minus 3.4. Third orbit minus 1.51. Fourth minus 0.85. Fifth minus 0.54. Sixth minus 0.37. Seventh minus 0.27. So like this we will be having infinite will be equal to 0. Infinite orbit will be having 0 energy. See, ಈಗಿಲ್ಲೇ ನಮಗೆ ಎಷ್ಟು orbits ಅದಾವ್ರಿ 1, 2 and 3. If an electron has to go from first orbit to second orbit, you have to give energy to that. From first orbit to second, third orbit, you have to give energy to that. ಅದಕ್ಕೆ ನೀವು energy ಕೊಡಬೇಕು. ಎಷ್ಟು energy ಕೊಡಬೇಕು? If the energy given to that electron is equal to E2 minus E1, energy of second orbit minus first orbit, then that electron will go from first to second orbit. If the energy given is equal to E3 minus E1, third orbit energy minus first orbit energy, that electron will go from first orbit to third orbit, higher energy state. Okay, so this is how much energy we have to give. And when that electron moves from ground state to higher energy state, that is called excited state. If second orbit andru excited and third orbit andru excited, because from where that electron has come from the first orbit, which is called ground state of that electron. ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಎಲ್ಲಿಂದ ಬಂದಿರ್ತದೆ ಅದಕ್ಕೆ ಹತ್ರ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಅಂತ ಕರೀತಾರೆ. ಅದ್ರ ಮೇಲ್ಗಡೆ ಇರುವಂತ ಎಲ್ಲ ಸ್ಟೇಟ್ಗೂ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ಸೊ ದಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಲ್ ನಾಟ್ ಪರ್ಮನೆಂಟ್ಲಿ ರಿಮೇನ್ ಅಟ್ ದ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್, ರೈಟ್? ಇಮಿಡಿಯೇಟ್ಲಿ ಇಟ್ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್ ಟು ದ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್. ಅದು ನಮ್ಗೆ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ವಾಪಸ್ ಬರ್ತದೆ. ಸೊ ವೆನ್ ಇಟ್ ಇಸ್ ಕಮಿಂಗ್ ಬ್ಯಾಕ್ ಟು ದ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್, ಇಟ್ ವಿಲ್ ಎಮಿಟ್ ಔಟ್ ದ ಎನರ್ಜಿ ವಿಚ್ ಇಸ್ ಅಬ್ಸಾರ್ಬ್ಡ್ ವೈಲ್ ಗೋಯಿಂಗ್ ಅಪ್. ಮೇಲ್ಗಡೆ ಶಿಫ್ಟ್ ಆಗ್ಬೇಕಾದ್ರೆ ಏನ್ ಎನರ್ಜಿ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡಿರ್ತದ್ರಿ, ಆ ಎನರ್ಜಿನ ಅದು ಎಮಿಟ್ ಮಾಡ್ತದೆ. right? So in this case, first note, when it is moving from second orbit to first orbit, energy emitted by that electron will be equal to E2 minus E1. E2 minus E1. What is the energy of the second orbit? That is minus 3.4, minus energy of first orbit, that is minus 13.6. Correct? So this will be minus 3.4 minus into minus plus 13.6, right? So if we see this, it will be how much? 10.5 something we will get, right? Okay, it will be, so 10.2 or 10.5 something we will get. So this much amount of energy it will release. ಎಷ್ಟು amount of energy na ಏನು ಮಾಡ್ತದ್ರಿ release ಮಾಡ್ತದ್ರಿ, right? So when it is traveling, when it is shifting from second to first, if it is shifting from third to first, then energy will be equal to E3 minus E1, right? E3 is how much? E3 is minus 1.51 minus minus of minus 13.6. Subtract ಮಾಡ್ಕೊಂಡ್ರೆ ನಿಮಗೆ ಎನರ್ಜಿ ಬರ್ತದೆ, right? While moving from ground state to excited state, it will absorb the energy, and while moving from excited state to ground state, it will emit the energy. Okay, so you better remember these energies so that you can easily calculate these values, correct? Next, see, current due to an electron motion in the orbit. Whenever an electron is moving in the orbit, in the circular orbit, it will constitute a certain current, and that current can be calculated by using the formula 1.06 z square divided by n cube. Z is atomic number, n is the principal quantum number. Magnetic field produced by that electron at the center of the orbit is given by 12.58 z cube divided by n raised to 5. Z cube divided by n raised to 5, right? So this is current constituted by the orbital electron, and this is magnetic field produced by that orbital electron. This current will be in milliamperes. Okay, next. See, ionization energy. What is ionization energy? See, if this is the nucleus and an electron is revolving around the nucleus in the circular orbit, if you want to remove this electron completely out from the influence of that nucleus, and if you want to keep it at infinite distance, how much energy is required to remove this electron? That is called ionization energy, and it is calculated by HCr z square into J. Sorry, J is unit, right? J is unit, joule. Joule ಒಳಗೆ ನಮಗೆ energy ಬರ್ತದ್ರಿ. HCr z square, where H is Planck's constant, C is speed of light, R is radius, and Z is atomic number. ಇದು ನಿಮಗೆ ಜೂಲ್ ಒಳಗೆ ಬರ್ತದ್ರಿ, and if you use this formula, you will get it in electron volts. Just divided by charge of an electron, you will get electron volts. Next, ionization potential. Ionization potential is nothing but just ionization energy divided by charge of an electron. That is ionization potential. Okay, next we'll go for a very important formula in this chapter, that is called wave number or reciprocal of wavelength. Nu bar represents wave number, lambda represents wavelength, which will be equal to z square r into the bracket 1 by n1 square minus 1 by n2 square. Z is actually atomic, is actually ನಾವು ಹೈಡ್ರೋಜನ್ ಅಟಮ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಹೈಡ್ರೋಜನ್ ಅಟಮ್ ನೀವು z is equal to 1 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ ನಾವು ಥಿಯರಿ ಒಳಗೆ ಯೂಸ್ ಮಾಡ್ಕೊಂಡಿದ್ದು ಫಾರ್ಮುಲಾ ಈ ತರ ಐತೆ. It will come like this: r into the bracket 1 minus n1 square minus 1 divided by n1 square minus 1 divided by n2 square, where n1 and n1 indicates ground state, n2 indicates excited state. R is Rydberg's constant, whose value is 1.097 into 10 raised to 7 per meter, right? Rydberg's constant 1.097 into 10 raised to 7 per meter. Okay, next, see, we know very well the series of lines which we get in the line emission spectrum of hydrogen atom, right? So in that first one is Lyman series, ground state of Lyman series. See, this indicates ground state, this indicates ground state, and this indicates excited state. E column namaga excited state and indicate ಮಾಡ್ತದೆ, right? So ground state and excited state. Okay, so we got to know for Lyman series, ground state is 1, and above 1 all are 2, 3, 4, 5, 6, those all are excited states, right? And this Lyman series comes under UV region of electromagnetic spectrum, right? Next, Balmer series, ground state of Balmer series is 2, excited state is 3, 4, 5, 6, so on. Paschen series, ground state is 3, excited states are 4, 5. See, Balmer series will come in visible region, and Paschen series and all other series below that will come in infrared region. Okay, well, Bracket series, ground state is 4, excited is 5, 6, 7. Fund series, ground state is 5, excited is 6, 7, so on, right? ಈಗ ನೋಡ್ರಿ, ಈಗ ಯಾವುದೋ ಒಂದು ಕ್ವೆಶ್ಚನ್ ಒಳಗೆ if they ask you find the wavelength of the second member of Balmer series, first member of Balmer series ಅಂತಂದ್ರೆ ಏನು? See, Balmer series ಅಂತಂದ್ರೆ its ground state is 2, Balmer series, right? Adra melgade excited state namagu 3, 4, 5 like this we will get. First member of Balmer series means it will be taking place, transition will be taking place from 3 to 2. Second member of Balmer series means the transition will be taking place from 4 to 2. Third member of Balmer series means it will be taking place from 5 to 2. Like this, we have to know the Balmer, the member of that series. Ella series ಒಳಗೆ ಅದೇ ತರ ಇದೆ. First member ಅಂತಂದ್ರೆ first excited state in the ground state. Second member ಅಂತಂದ್ರೆ second excited state to the ground state. Like that we have to take. Okay. See, in next, in Balmer series, there are some special lines called as H alpha line, H beta line, H gamma line, and H delta line. All these are present in Balmer series. So ground state is fixed. N1 is equal to 2. Excited state for H alpha 3, for H beta 4, for H gamma 5, for H delta 6. Andre first member of Balmer series is H alpha, second member is H beta, third member is H gamma, fourth member is H delta. Correct? Like this we have to take it. Okay. Next. For shortest transition ಅಂತಂದ್ರೆ ಏನ ಈಗ ನೋಡ್ರಿ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ನಮಗೆ 1 ಅದ ಅಂತ ಇಟ್ಕೋರಿ ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ 2, 3 so on up till infinity ಇರ್ತದೆ. Shortest transition ಅಂತಂದ್ರೆ second to 1. This is the shortest transition. If transition is shortest, then wavelength will be longest. Wavelength ನಮಗೆ longest ಇರ್ತದೆ. If transition is shortest, wavelength is longest. If transition is longest, infinity to 1 transition ನಮಗೆ ಇತ್ತಪ್ಪ ಅಂತಂದ್ರೆ wavelength will be shortest. Wavelength ನಮಗೆ shortest ಇರ್ತದೆ. Correct. For example, ಈಗ ನಿಮಗೆ ಹೇಳ್ತಾರೆ ಬಾಲ್ಮರ್ ಸೀರೀಸ್ ದ ಲಾಂಗೆಸ್ಟ್ ವೇವ್ ಲೆಂತ್ ಫೈಂಡ್ ಮಾಡ್ರಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಬಾಲ್ಮರ್ ಸೀರೀಸ್ ದ ಲಾಂಗೆಸ್ಟ್ ವೇವ್ ಲೆಂತ್. ಲಾಂಗೆಸ್ಟ್ ವೇವ್ ಲೆಂತ್ ಅಂದ್ರೆ ಟ್ರಾನ್ಸಿಷನ್ ಶಾರ್ಟೆಸ್ಟ್ ಇರ್ಬೇಕ್ರಿ. ಟ್ರಾನ್ಸಿಷನ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಶಾರ್ಟೆಸ್ಟ್. ಸೊ ಟ್ರಾನ್ಸಿಷನ್ ಶಾರ್ಟೆಸ್ಟ್ ಇನ್ ಬಾಲ್ಮರ್ ಸೀರೀಸ್. ಬಾಲ್ಮರ್ ಸೀರೀಸ್ ಅಂದ್ರೆ ಫಸ್ಟ್ ಥಿಂಗ್ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಇಸ್ 2 ಫಿಕ್ಸ್ ಅದು. ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಇಸ್ 2. ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಇಸ್ 2. ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ಇಸ್ 2. ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ನೋಡ್ರಿ ಶಾರ್ಟೆಸ್ಟ್ ಅಂತಂದ್ರೆ ಶಾರ್ಟೆಸ್ಟ್ ಟ್ರಾನ್ಸಿಷನ್ ಅಂತಂದ್ರೆ excited state should be 3. Excited state should be 3. Suppose if they ask you find the shortest wavelength, then transition has to be longest. Since the series is Balmer series, ground state will be fixed. Excited state will be infinite to get longest transition. Right? Like this we have to take it. Next, number of possible transitions by spectral lines from nth state of hydrogen atom is n into the bracket n minus 1 divided by 2. This will give you number of possible transition or spectral lines from nth state of hydrogen atom. Right? Okay, that's how we have to calculate number of possible transitions. Next, we'll go for nuclei. See, in nuclei, first you should be knowing the mass of proton. Mass of proton is 1.672 into 10 to the power minus 27 kg. Mass of neutron is 1.674 into 10 to the power minus 27 kg. It is slightly heavier than the nucleus, than the proton. Mass of electron is 9.1 into 10 to the power minus 31 kg, which is very much lighter compared to proton as well as neutron. How much lighter? Mass of one proton is equal to 1840 times of mass of electron. Andre 1840 electrons ಕೂಡಿಸಿದಾಗ ಒಂದು proton ನಮಗೆ ಆಗ್ತದೆ. Okay, next, we know very well a nucleus is represented by in this way. It is represented scientifically like this. X is the nuclei, A is the mass number, Z is the atomic number. Z atomic number which tells us about number of protons or number of electrons. However, how many number of protons are present in the nucleus? Same number of electrons will be present outside the nucleus in the circular orbits. So Z indicates number of protons or electrons. A indicates number of nucleons. Nucleons ಅಂತಂದ್ರೆ number of protons and neutrons together. Nucleus ಒಳಗಡೆ ಎಷ್ಟು number of protons ಮತ್ತು neutrons ಅದಾವ, that is indicated by A. Number of neutrons is represented by A minus Z. Number of neutrons andre if you subtract A and Z, you will get number of neutrons. Right? Okay, that's all about how we represent a nucleus. Next, isotopes ಅಂತಂದ್ರೆ ಏನ್ರಿ? Isotopes means here atomic number will be same. Isobars mass number will be same. Isotones number of neutrons will be same. Isomers Z and A atomic number and mass number both will be same, but they will differ in nuclear properties such as radioactive decay and magnetic moments. E properties olaga differ agtave. Those are called isomers. Right? Okay, next, radius of the nucleus is connected with mass number in this way. R is equal to R naught into A raised to 1 by 3, where R naught is a constant whose value is 1.3 Fermi. Fermi antandre 10 to the power minus 15 meter. Right? Radius of the nucleus will be in the order of 10 to the power minus 15 meter. Radius of atom will be in the order of 10 to the power minus 10 meter. Angstrom ಒಳಗೆ ಇರ್ತದ್ರಿ, ಇದು Fermi ಒಳಗೆ ಇರ್ತದ್ರಿ. Right? Okay. See, volume of the nucleus. Nucleus will be spherical in shape. That's why volume is 4 by 3 pi r cube. So it indicates that volume is directly proportional to R cube. Volume is directly proportional to R cube. And since R is directly proportional to A raised to 1 by 3, hence volume will be directly proportional to A, mass number, right? Okay, that is the relation between volume, radius and mass number. Density of all the nuclei will be same. Density is constant for all nucleus, all types of nucleus. And it is 2.3 into 10 raised to 17 kg per meter cube. This much will be the density of all the nucleus. It may be uranium, it may be lithium, right? So density will be same for all. Next, what is the mass of 1 AMU in kg? 1 atomic mass unit. See, AMU is the smallest unit of mass we use, right? When you go for intra-atomic particles, we cannot use the bigger units like kg, joule and all. Kg, joule, meter, kilometer. Like this, ಯಾವುದೇ length dagli, mass dagli, energy dagli, bigger units ಗಳನ್ನು use ಮಾಡ್ಲಿಕ್ಕೆ ಬರೋದಿಲ್ಲ because they are very small. That's why we use smaller units. For mass we use AMU, for energy we use electron volts, for distance we use Fermi or angstrom, right? Like that it is. So value of 1 AMU is 1.66 into 10 to the power minus 27 kg. Kg ಒಳಗೆ ನಮಗೆ ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ ಬರ್ತದೆ 1 AMU ದ, and energy of 1 AMU is 931 mega electron volts. Mega means it is 10 to the power plus 6. You remember 10 to the power plus 6, right? So 1 AMU the energy 931 mega electron volts irtadri, right? Okay, next, mass defect. See, mass defect antandre, see, if this is a nucleus, and let me say there are 2 protons and 2 neutrons, 2 protons and 2 neutrons. So ಇದು ಕಂಪ್ಲೀಟ್ಲಿ ಸ್ಪೆರಿಕಲ್ ನ್ಯೂಕ್ಲಿಯಸ್, ಒಂದು ನ್ಯೂಕ್ಲಿಯಸ್ ಫಾರ್ಮ್ ಆಗಿತ್ತು ಈಗ ಆಲ್ರೆಡಿ. ಆ ನ್ಯೂಕ್ಲಿಯಸ್ ಮಾಸ್ ನಮಗೆ m ಅಂತಿರ್ಲಿ. ನಾವು ಐ ವಿಲ್ ಬ್ರೇಕ್ ದಿಸ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂಡ್ ಐ ವಿಲ್ ಸಪರೇಟ್ ದೋಸ್ ಪ್ರೋಟಾನ್ಸ್ ಅಂಡ್ ನ್ಯೂಟ್ರಾನ್ಸ್. ಆ ನ್ಯೂಟ್ರಾನ್ಸ್ ಮತ್ತು ಪ್ರೋಟಾನ್ಸ್ ಎಲ್ಲಾನು ಸಪರೇಟ್ ಮಾಡ್ತೀನಿ. ಈಗ ಇವೆಲ್ಲಾನು ಸಪರೇಟ್ ವೇ ಮಾಡ್ತೀನಿ. ಐ ವಿಲ್ ಸಪರೇಟ್ಲಿ ವೇ ಆಲ್ ದೀಸ್ ಥಿಂಗ್ಸ್. Mass of 1 proton plus mass of 1 proton plus mass of neutron plus mass of neutron. Now, how much mass you get here? This mass will not be equal to this mass. ಈ ಇಂಡಿವಿಜುವಲಿ ನೀವು ವೇ ಮಾಡಿದಾಗ ಏನ್ ಮಾಸ್ ಇರ್ತದಲ್ಲ, ದಟ್ ಮಾಸ್ ಅಂಡ್ ದಿಸ್ ಮಾಸ್, ರೆಸ್ಟ್ ಮಾಸ್ ಆಫ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಅಂದ್ರೆ ಕಂಪ್ಲೀಟ್ಲಿ ಸ್ಪೆರಿಕಲ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಇದ್ದಾಗ ಏನ್ ಮಾಸ್ ಇರ್ತದೆ, ದೀಸ್ ಬೋತ್ ವಿಲ್ ನಾಟ್ ಬಿ ಈಕ್ವಲ್. ದೇರ್ ವಿಲ್ ಬಿ ದ ಡಿಫರೆನ್ಸ್ ಇನ್ ದ ಮಾಸ್, ಅಂಡ್ ದಟ್ ಡಿಫರೆನ್ಸ್ ಇನ್ ದ ಮಾಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಮಾಸ್ ಡಿಫೆಕ್ಟ್. It is calculated by ZMP plus A minus ZMN minus M, where Z is number of protons, MP is mass of 1 proton. So total number of protons into mass of 1 proton will give you mass of total number of protons. Next, A minus Z Mn, A minus Z, mass number minus atomic number will give you number of neutrons. So idu number of neutrons, idu mass of neutron, idu mass of nucleus. When all the neutrons and protons together form a nucleus, spherical nucleus, ಅವಾಗ ಅದರದ್ದು ಎಷ್ಟು ಮಾಸ್ ಅದ, that is m. Correct? Okay, ZMP plus A minus ZMN minus M. This is mass defect. Next, where M is mass of nucleus, it is given here. In binding energy ಅಂತಂದ್ರೆ ಏನು? We know very well binding energy is the energy required to break a nucleus into its constituent particles, or combine the energy required to combine the constituent particles into a spherical nucleus. ಒಂದು ಸ್ಪೆರಿಕಲ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಬ್ರೇಕ್ ಮಾಡಿ ಅದರ ಕಾನ್ಸ್ಟಿಟ್ಯೂಯೆಂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಒಳಗೆ ಸಪರೇಟ್ ಮಾಡ್ಲಿಕ್ಕೆ ನಿಮಗೆ ಏನ್ ಬೇಕಲ್ಲ ಎನರ್ಜಿ, ಅದಕ್ಕೂ ಬೈಂಡಿಂಗ್ ಎನರ್ಜಿ ಅಂತ ಕರೀತಾರೆ. ಅಥವಾ ಸಪರೇಟೆಡ್ ಇರುವಂತಹ ನ್ಯೂಕ್ಲಿಯನ್ಸ್ ಗಳನ್ನ ಕಂಬೈನ್ ಮಾಡಿ ಒಂದು ಸ್ಪೆರಿಕಲ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಫಾರ್ಮ್ ಮಾಡಬೇಕಾದ್ರೆ ಏನ್ ಎನರ್ಜಿ ಬೇಕು ಅದಕ್ಕೂ ಕೂಡ ಬೈಂಡಿಂಗ್ ಎನರ್ಜಿ ಅಂತ ಕರೀತಾರೆ. And its formula is mass defect into 931. This will give you binding energy in terms of mega electron volts, right? So if you want the energy in mega electron volts, mass defect into 931. If you want the energy in joule, mass defect into c square. This will give you energy in joule. Next, specific binding energy. Specific binding energy is binding energy per nucleon. Antandre binding energy divided by mass number. What specific binding energy indicates? If the specific binding energy is more, that nucleus is very stable. You cannot break that nucleus easily. ನೀವು ಅದನ್ನ easily break ಮಾಡ್ಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ, right? So binding, more the binding energy, more stable is the nucleus, right? So that's all about specific binding energy. Next ನೋಡ್ರಿ, specific binding energy curve ನಾವು ಥಿಯರಿ ಒಳಗೆ ನೋಡ್ಕೊಂಡಿರ್ತೀವಿ. The curve is like this. Starting it will increase suddenly and you will find maxima and minimas here, and it will reach the maximum, again it will decrease. So this type of specific binding energy versus mass number curve we have seen. Specific binding energy on y-axis, mass number on x-axis. Correct? See, specific binding energy is maximum for ferrous, whose mass number is 56. And how much is the specific binding energy of that? 8.8 mega electron volts. And then it goes on decreasing, even though uranium-238 is heavier, bigger nucleus than ferrous, but it has lesser specific binding energy, that is 7.6. So ferrous is more stable than uranium. Specific binding energy is minimum for deuteron. 1H2 deuteronic minimum ada how much it is 1.1 mega electron volt, and it is maximum for ferrous whose value is 8.8 mega electron volts, right? Okay, ಆಮೇಲೆ ಇಲ್ಲಿ ನೀವು ನೋಡಬಹುದು all the elements which are having even atomic number are in maxima and odd atomic number are in minima. So elements which are present in maxima will be more stable than the elements which are present in the minima, right? Okay, next, if the mass number of the nuclei is greater than 220, it will be unstable and it will undergo fission, nuclear fission. If the atomic number is less than 20, even though it is then also it is unstable, but it will not undergo fission, it will undergo fusion. Both are unstable. 220 ಕಿಂತ ಜಾಸ್ತಿ ಇದ್ರೂ unstable, 20 ಕಿಂತ ಕಮ್ಮಿ ಇದ್ರೂ unstable. But 220 ಕಿಂತ ಜಾಸ್ತಿ ಮಾಸ್ ನಂಬರ್ ಇತ್ತಪ್ಪ ಅಂದ್ರೆ ಅವು ಹೆವಿ ನ್ಯೂಕ್ಲಿಯಸ್ ಇರ್ತಾವೆ, ದೇ ವಿಲ್ ಅಂಡರ್ಗೋ ನ್ಯೂಕ್ಲಿಯರ್ ಫಿಷನ್. 20 ಕಿಂತ ಕಮ್ಮಿ ಮಾಸ್ ನಂಬರ್ ಇದ್ರೆ ಅವು ಲೈಟರ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಇರ್ತಾವೆ, ದೇ ವಿಲ್ ಅಂಡರ್ಗೋ ಫ್ಯೂಷನ್, ರೈಟ್? ನೆಕ್ಸ್ಟ್, ಎನರ್ಜಿ ರಿಲೀಸ್ಡ್ ಇನ್ ಎನಿ ರಿಯಾಕ್ಷನ್. ನಿಮಗೆ ಏನೋ ಒಂದು ರಿಯಾಕ್ಷನ್ ಕೊಟ್ಟಿದ್ದಾರೆ, 1H2 plus 1H2, it is like this, 1H2 plus 1H2, this will give you 1H2 plus 1H2, this will give you 2He4, 2He4 plus some amount of energy is released ಅಂತ ತಿಳ್ಕೊಡ್ರಿ, ರೈಟ್? ಈಗ ಏನಾಗ್ತದ್ರಿ, ಇಲ್ಲಿ ನೀವು ಎನರ್ಜಿ ರಿಲೀಸ್ಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ, ಎನರ್ಜಿ ರಿಲೀಸ್ಡ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಟೇಕ್ ಫಸ್ಟ್ ಮಾಸ್ ಡಿಫೆಕ್ಟ್. ಮೊದಲು ಮಾಸ್ ಡಿಫೆಕ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ರಿ. ಐದರ್ ಮಾಸ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಮೈನಸ್ ಮಾಸ್ ಆಫ್ ಪ್ರೊಡಕ್ಟ್ಸ್ ಆರ್ ಮಾಸ್ ಆಫ್ ಪ್ರೊಡಕ್ಟ್ಸ್ ಮೈನಸ್ ಮಾಸ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್, ದಟ್ ವಿಲ್ ಗಿವ್ ಮಾಸ್ ಡಿಫೆಕ್ಟ್. ಇಲ್ಲೇ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಮತ್ತು ಪ್ರೊಡಕ್ಟ್ಸ್ ಮಾಸ್ಗಳನ್ನು ಮೈನಸ್ ಮಾಡ್ಕೊಡ್ರಿ, ನಿಮಗೆ ಮಾಸ್ ಡಿಫೆಕ್ಟ್ ಸಿಗ್ತದೆ. ಅಂಡ್ ಮಲ್ಟಿಪ್ಲೈ ದಟ್ ಮಾಸ್ ಡಿಫೆಕ್ಟ್ ಬೈ 931, you will get the energy in terms of mega electron volts. So that is said to be the energy released in this reaction, right? Okay, next, packing fraction. See, packing fraction means how tightly the nucleons are packed. So it is mass number minus mass, molecular mass of the nucleus minus mass number divided by mass number, or mass defect divided by mass number. If packing fraction is positive, and it will be positive for nucleus which are having mass number greater than 200. If it is positive, the nuclei is said to be unstable. If it is negative, the nuclei is said to be stable. And for C612, for carbon 12 isotope, packing fraction is 0, right? Packing fraction will be positive for nucleus having mass number greater than 200. Packing fraction will be negative for nucleus having mass number greater than 20 and less than 220, right? Okay, next, multiplication factor. Multiplication factor is the ratio of number of neutrons in one generation divided by number of neutrons in previous generation in a nuclear chain reaction. See, there are two types of nuclear reactions we know, nuclear fission as well as nuclear fusion. Nuclear fission ಒಳಗೆ ಮತ್ತೆ ನಿಮಗೆ chain reaction ಬರ್ತದ್ರಿ, ಅಲ್ಲಿ ಮತ್ತೆ controlled chain reaction, uncontrolled chain reaction, we know, right? Controlled chain reaction is the principle of nuclear reactor, uncontrolled chain reaction is the principle of atom bomb. So ಈಗ ಆ chain reaction growth ಆಗ್ತದೋ ಅಥವಾ stagnant ಉಳಿತದೋ ಅಥವಾ whether that chain reaction will stop, ಅದು ಇದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದ್ರಿ. It depends upon the value of k ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗ್ತದ್ರಿ. If k is greater than 1, chain reaction grows, it means it continues. If k is equal to 1, chain reaction remains steady, it will neither grow, it will not die. And if packing fraction is if multiplication factor k is less than 1, then chain reaction dies earlier, it will get end soon, right? That is all about the multiplication factor. Okay, so dear students, that's all about atoms and nuclei. Rest of the theory you have to read from your theory notes, and this is all about this chapter, atoms and nuclei. Dear students, I request you, please don't forget to subscribe the channel and share the channel, share the video with your friends. Please refer the channel for your juniors. If you find the content in this channel useful, please refer it to your juniors as well as to your friends, right? Thank you so much for watching and supporting the channel. Please keep watching and supporting the channel. Thank you.